Hi everyone, I'm Clara Bayarri. I'm an engineering manager on the Toolkit team, working on large screens and Jetpack Compose.
And I'm Muntenescu. I'm a developer relations engineer at Google.
So you may have seen Android Developer Summit was this week, and we announced a bunch of different things. Especially, I want to highlight 12L feature drop. If you saw this, we've announced a bunch of features coming to Android, especially for tablets and large screens. We also announced a bunch of changes to Play Store that affect apps. So there's a lot going on in this space this week. But today we're here to talk about developer. So we're going to focus on APIs and tools, and how do you target that large screen, right? How do you scale your app from a small screen to a larger screen? I'm going to walk you through kind of different things, but before all of that, why are we talking about large screens, right? Like, why is this week so kind of a large screen moment? Well, in the last 12 months, we've seen 100 million new tablet activations on Android, which is huge. And we've seen a 92% growth in Chrome OS. This is the fastest growing desktop operating system at the moment. So it's huge, and it means there's 250 million Android devices that are either tablets, foldables, or Chrome OS devices, sorry. So it's a very big market. It keeps growing. One of the pieces that we consider a large screen is foldables, and foldables are especially on the rise. We've seen a 250% growth in the last 12 months, which is just ridiculous. And there's a lot of carriers and device manufacturers that are really recognizing foldables is how we really break into the premium segment. It is a huge opportunity. It is really growing. It is exciting. So we're seeing tremendous growth there. So we feel like now is the time. Like, stop thinking about phones, stop thinking about tablets, start thinking about one app that targets the ecosystem. If we can get you to build one app that does all of them, you're suddenly increasing the reach of your app just tremendously, right? Like, this is a very big opportunity for developers. On top of that, we announced a bunch of Play Store updates. So the Play Store is going to be introducing in the next couple of months per device type app ratings, which means that we will have different ratings for your app depending on the type of device. So you will have large screen specific ratings. It is now the moment, like, optimize for large screens now to make sure you have those nice ratings when this kicks in, and you don't see a penalty in large screens. Also, it is now the moment, because with part of what we announced for 12L feature drop is that we will be letterboxing apps that can't actually scale properly to a large screen. And this is kind of awkward. It solves some issues of apps that won't scale, but it's not the best experience for your users. Now, what's the carrot? Well, we've seen a lot of user engagement, and we want to highlight some of the use cases that we've been working for. This is Candy Camera, which is a popular app, I think in Korea, especially. But they've seen tremendous opportunity. They've been implementing a bunch of large screen and foldable specific use cases. For example, they have this snap and view mode, which is tabletop on foldables. And this has meant that they've seen people who are using these devices are spending 10% more time in the app, and they see an increase in 14% of the 7-day user retention, which is huge for this market. And it's not just Candy Camera. We have a lot of other apps that are really targeting large screens and trying to make these use cases really shine. Another interesting example is Microsoft Outlook. They've been really working on their large screen story. They now have, Outlook has this 2-pane mode where you can see your list of emails and an open email, but they've also been optimizing for being able to compose new emails in a separate window for multiple displays like the Surface Duo. So if you want to take one thing away, is now is the time to start building these adaptive experiences. Start targeting the large screen now and really take care, because there is this huge part of the ecosystem that a lot of apps are not targeting right now and is really crucial to get right. But don't worry, we're going to help you. You're not on your own. We are going to be talking through a bunch of different design guidance and different developer tools and APIs that you can use. So stick with us for the next 30 minutes, and we'll guide you through some of them.
So we heard from you that knowing what screen size to design and develop for is difficult within our growing ecosystem of devices. So we're working hard on making it straightforward for you to build a responsive UI that works well across phones, tablets, and foldables. So for the future of resizable Android apps, we dug deep into the Android market representation. So we also took some inspiration from the responsive and adaptive web development best practices. The result is a new foundation for building resizable Android UIs. And this new system is called window size classes. Window size classes are a set of opinionated viewport breakpoints for you to design, develop, and test your resizable application layout against. These breakpoints will help you understand the key sizes to optimize your app, to ensure that your app covers as much of the ecosystem as possible. The window size class breakpoints have been broken into 3 categories: compact, medium, and expanded. And they have been designed specifically to balance the layout simplicity with the flexibility to optimize your app for the most unique use cases. The recommended usage for these breakpoints is to make high-level application layout decisions, and they also map to the material layout breakpoints for layout grid column changes. The new window size class APIs will be coming to Jetpack WindowManager 1.1, and they will enable you to break away from the error-prone is tablet Boolean logic, which, to be honest, has become quite fragile, especially with the introduction of foldable devices. These new APIs will also negate the need for custom logic around landscape and portrait configuration, and then for most cases. So you'll just be able to design for different window size class breakpoints, and then your app will just adapt to the right layout in various app states. And then one important thing to mention is that Android applications can be arbitrarily resizable, and all applications run in multi-window mode starting with Android 12. We've actually seen a 7 times increase in split screen usage on devices like the Samsung Galaxy Fold series from the large screen real estate that the unfolded device provides. So split screen apps can be resized to match user preferences. So this means that it's even more important to think about resizable UIs. So we also recognize the familiarity of thinking about layouts in terms of devices and configurations. So to make things a little bit easier, each size class breakpoint represents a majority case for typical devices and configurations out there. So this can be a helpful frame of reference when you think about design based on these breakpoint-based layouts. So more precisely, compact width represents your typical phone in portrait mode. Medium width represents tablets and large foldable inner displays in portrait mode. And then expanded represents tablets, larger foldable inner displays, and desktops in landscape mode. In addition to these 3 width-based breakpoints, we're also introducing height-based breakpoints with the same category names to provide additional flexibility for more advanced layout scenarios. So for example, maybe you want to optimize your landscape phone UI using the compact height breakpoint. We've heard that this can be a little bit complicated, but don't worry. After speaking with a lot of Android developers, we have evidence to suggest that actually you'll only need to adapt your applications based on width. So to summarize, window size classes represent a big step in adaptive and responsive layout development across updated and improved guidance, new APIs in Jetpack WindowManager, and new tools in Android Studio. And speaking of Android Studio, we have a new category of tools coming to Android Studio Bumblebee called reference devices. Since Android apps should be built to respond and adapt to all devices and categories, we're introducing reference devices across Android Studio in many of the tools you design, develop, and test UI and layout. So the 4 reference devices represent phone, larger foldable inner displays, tablets, and desktops. These references have been designed after analyzing market data to represent either popular devices or rapidly growing segments. And they were also designed to ensure that your app works across most window size class combinations. So if you just take one thing from this talk, is this checklist. To make sure that your application scales across devices, optimize your layout for both compact and expanded width. Next, test your app across all reference devices. Every app is different, so pick the layout that works best on medium width size class for your app. And then make your app really stand out. So consider additional improvements such as custom layouts for foldable hinge postures or custom layout for medium width breakpoints or height breakpoints. Also, don't forget about how your users interact with your app. So think about working with stylus or keyboard or mouse. You can find more details about window size classes in our documentation, and you'll actually see window size classes and reference devices appear all throughout this talk. If you want to see them in action, check out our Jet News Compose sample that uses them.
So the first step to supporting an adaptive UI is thinking about design, right? Like you want to make sure you have a design for your app that works nicely on the phone, which you're probably more used to, and on a large screen. It's quite intimidating. There's a lot to handle, right? Like there's new use cases, new additional screen space to consider, new flows in your app probably. So where do you start? Well, we've published a bunch of new material design guidance specifically targeted towards large screens and adaptive UI. We've published what we call the canonical layouts, which are different styles of layouts, as you can see in the slide, that are very prevalent in the ecosystem. So we analyze different apps behaving in large screens. What are they doing, and what can we help inspire you with typical structures that will really help you fill in that space? On top of that, we have a bunch of new design guidance. So look at that, and it should help you inspire and see what could you do with your app. It will suggest layouts and just general different features that you can build to really make your app stand out. But we know designing is the first step. What we're really worried as developers is usually building and maintaining, which is really the complicated part of having large screen support. So we're going to introduce you a couple of things that we can do, both for existing apps, for Compose apps, and in tooling to help you with that.
Cool. So let's start with views. So let's see how we can update an existing app to rapidly optimize all screen sizes with the help of new Jetpack APIs and Android Studio features. So we'll use Tracker. This is one of our open source applications that initially was developed to showcase accessibility, but it's a really good example of this kind of like task-based application where we optimize for large screens. So let's see exactly what we did to make Tracker work great on large screens. So before we make any changes, this is how Tracker looked. So regardless of device or setting, we had a single pane of list of tasks with a bottom app bar for navigating to archives or settings screen. The application had 5 main views. So a list of tasks, each task detail, a screen to create or edit task, and a settings and archives view. The navigation graph, before we've done any large screen optimizations, flowed something like this. So we had the list of tasks acting like a home page, enabling navigation to the settings or archive page. Now, let's optimize this. If you're not sure where to start with your application, the first thing you can do is use the new tools we have to identify potential issues impacting large screen devices. In Android Studio Chipmunk, we're working on new visual linting tool to surface warnings and suggestions in layout validation. So in Tracker, we use the layout validation on existing layouts to surface some potential large screen related issues. So I started on the top of my navigation tree to get a good high-level overview of how my app will behave. So I opened the main activity layout, and then I opened the layout validation tool. You can also go to the layout validation with View, Tool, Windows, and then select it there. So the first thing you might notice in the layout validation is actually the new reference device validation category. And this one area where you will see the new reference device feature appear in Android Studio. And then I see a warnings icon in the top of the layout validation. And then clicking that warning pane, clicking that warning button opens this warnings pane down there, where I will be able to see which reference devices are impacted. So in this case, I actually see 2 warnings specifically related to large screen layouts. So the first one is that the bottom app bars are recommended for compact screens, and that material text view has lines containing more than 120 characters. So I can expand each warning to see that the warning also provides a suggestion of how to fix this. So the suggestion for the warning related to the bottom app bar is to use a navigation rail, navigation drawer, or top app bar instead. So for Tracker, I think it makes most sense to use a navigation rail. The suggestion for the warning about material text view control is to either decrease the width of the text view or consider a multi-column layout instead. In this case, a multi-column layout would work great for our app. So let's resolve these warnings by implementing a typical list detailed pane style for the tasks list. So to recap, our desired end state will have 2 layout optimizations. First, for medium width device classes and larger, we'll have a navigation rail instead of this bottom app bar. And then for expanded width devices, we'll also present a 2-pane layout to show tasks and associated details. Let's start by focusing on navigation rail. So the first thing we need to think about is our navigation model. Fortunately, our navigation graph impact is minimal. We aren't changing the screens we need to navigate to, but the nav rail will now expose the full navigation graph on each display because the nav rail will always be present. With that in mind, our updated navigation graph would look like this. The app start destination is still the task screen, and selecting an individual task will navigate to task details. However, from the nav rail, I can navigate to any other view. To implement this pattern, I can add a navigation rail view to my main activity layout. Previously, the main activity consisted of just a fragment container view with a coordinator layout to host the other fragments through the nav host fragment. By placing the navigation rail view at the main activity layout, it will persist across all views. That said, I only want the navigation rail for screen sizes with a width of 600 dp or larger. So one easy way to achieve this is to add a resource-qualified main activity layout, and then add the navigation rail view at the same level as the fragment container view containing the nav host fragment. We'll also want to update our task fragment to remove the bottom app bar from displays with a width of 600 dp or greater. So similar to how I implemented the nav rail, I can add the resource-qualified layout for the tasks fragment. And then I can remove the bottom app bar and associated floating action button. Everything else remains the same so that my list of tasks hosted in Recycler View will just continue to work as expected. Lastly, I can set up the ID of my navrail menu item to match the ID of my existing navigation destinations. And then I set up the nav controller for my navrail in the main activity code. Now that's done, let's look at Android Studio and see, do things look right? So we're bringing reference devices to the layout editor. So as I'm working on these updates, I can quickly toggle between the various reference devices to make sure I'm seeing the expected layout. When looking at the phone reference device, I still see the bottom app bar as expected, but then looking at anything larger, that's the nav rail. So that's great. So now that our application is using a navigation rail, let's move on to display a two-pane view for expanded width devices. One easy way to support a two-pane layout is by using sliding pane layout. So what's great about the sliding pane layout is that it allows me to easily reuse existing layout code. So let's look again at the navigation graph. As a quick refresher, this is how the current state of our app is. The navigation rail allows me to navigate to any top-level layout within my application, and I can still navigate from the task fragment to the details fragment by selecting any individual task. When we implement the sliding pane layout, our navigation graph is going to change a little bit because we are adding a new layout, two-pane task, to include the sliding pane layout. This will be the new start destination for our application's navigation graph. So this layout will contain both the tasks and the details fragment. By updating our application's navigation this way, we'll have the same navigation graph for the app regardless of screen size. So this means that resize events won't confuse users with unexpected app navigation. Because both tasks and detail will be presented in the same new fragment in sliding pane layout, we'll add a new sub-navigation hierarchy specifically for the interaction with this fragment. This will make sure that when I select a task and then my app goes from two-pane to one-pane, the item will be on the top of the navigation graph and will be visible. This could happen when I'm folding my foldable device, for example. So to be more succinct, the navigation from task to individual details will be broken out of the application's top-level navigation hierarchy and will be managed separately by the sliding pane layout. So this is what I will do. I'm adding a new fragment using sliding pane layout and fragment container view to host the task and the details pane. And then this means that I don't have to do any major refactoring in my layout code, which is great. I can be lazy. Then I will update my top-level app navigation hierarchy to make the two new pane fragment my app's start destination and remove the details destination from the app's navigation graph. Next, I'll add a new navigation graph specifically for the sliding pane layout. And then finally, I'll handle the sliding pane layout nav controller configuration logic in my two task pane fragments called Kotlin code. Okay, With these changes made to our application, I think this will look much better across different device form factors. So first, we're looking at the layout validation for the main activity, and everything seems to be looking right. So we see the right layout for each reference device in one view. Okay, now let's test things at runtime. So we can use the new resizable emulator coming with Android Studio Chipmunk. The resizable emulator lets me quickly toggle between the same reference devices. So this means that you can rapidly go from validating your layout at design time to using layout validation with reference devices to confirming the behavior at runtime using the resizable emulator and the same reference devices. So I see that I have a single pane application with a nav rail on foldable inner screen displays. So this represents the medium width size class. And then when I try the phone display, I get the single pane view with the bottom app bar. So that's the compact width size class. And then here, when I'm testing on a tablet or a desktop, we get the nav rail with the 2 panes. One other great attribute of the sliding pane layout is that it scales well not only on large screen devices, but also on devices with multiple screens. Microsoft recently contributed to sliding pane layout to support hinge detection to split the panes across displays in the presence of a physical hinge. So you can do this without adding any additional code. So this means that our application's new list detail layout will scale well to all devices, including those, like this one here, with multiple displays. So with those changes, we have a much more adaptive Android application optimized for each width-based window size class breakpoint. While this is a great way to apply a large screen optimized layout to an application using fragments, we know that a lot of you might have applications using multiple activities. For those apps, the new activity embedding APIs released in 12L will make it easy to support new UI paradigms, such as the 2-pane view. One other thing we're working on is updating a sliding pane layout to support using multiple activities with the new activity embedding APIs. So keep an eye for an update in the next few months.
So we've talked about how to enable your view, but obviously we're very excited to introduce Compose as one of the key tools that you can use to really optimize for large screens and just different screen sizes. Compose reached 1.0 in July, and we've seen tremendous reaction from the community. We now have tens of thousands of apps shipping Compose in production, which for the team is a huge kind of height moment. We really want to encourage you, like while you're adopting Compose, we know a lot of you are doing that out there, it's a great opportunity as well to be targeting large screens, because while you're doing that transition, it turns out Compose really helps you do this. For those who are not familiar, Compose is a declarative UI toolkit, meaning that you describe your UI in code, and Compose takes care of any UI updates for you. Everything is described at runtime, meaning it's actually really easy to describe different screen configurations with a simple if-else. You can describe all of these things, and it really helps you build adaptive UI in a way that views had a hard time, because if you think of views, you have to describe the different layout configurations in separate files that get handled at compile time. Compose does all of this at runtime, which is much, much, much easier. No matter how many improvements we try to make, you've seen we've done a bunch of improvements to views, but no matter how much we do on the views side, it's never gonna be as easy as it is with Compose. So let me walk you through, we've been really working on Jet News. It is our showcase sample for Compose, and we've been updating it to large screens over the last few months. So let me walk you through some of the things we've done and what we've used in Compose for it. So this is the main screen in Jet News. It is a long scrolling list of articles. And before we did any work, surprise, when you scale it to a large screen, it actually didn't look that great, right? Like everything just stretches, and we weren't making good use of the space. So we decided to do something. But because we do everything at runtime, before we can actually make any changes, we need to know how to decide when our UI is being showed in a large screen in code, right? So for that, we're gonna look at window size classes that we introduced earlier and how to use those in Compose. So we covered earlier, there's APIs coming in WindowManager 1.1 that will help you really deal with window size classes. We're working on a Compose integration for that as well. It's not ready yet, but in the meantime, we can show you how to hack that together yourself, and hopefully soon we'll have APIs. So to be able to currently manage the integration between WindowManager and Compose, we just need to build a composable function that does that integration for us. First, we're going to reach into the window metrics of the backing activity and remember that correctly into compose state, just to make sure we are observing all changes to these metrics. And then we can translate those into an available DP size, right? And this is going to give us what is the screen space that our app has. And then finally, we translate that to one of the classes that we've introduced. So is it compact, medium, or expanded? As I said, like, APIs to do this for you are coming soon. In the meantime, you can borrow this code from JetNews. This is pulled straight from JetNews. So really easy to go copy that from there. So now that we know how to gate changes, what do we do? Well, we saw in Tracker, the first thing we look at usually is the navigation UI. We saw before Tracker had the bottom app bar and the bottom navigation. In the case of JetNews, we have something a bit different. We have a navigation drawer that comes out of the side when you hit the icon in the top app bar. Again, surprise, when you run this in a large screen, it looks terrible. We had done nothing specific, and then the drawer just kind of tries to fill as much of the space. That's a lot of white, and it will blind you if you see this. So we're going to do something about this. And as we saw earlier, the easiest path forward is for medium and expanded sizes to use a navigation rail. Well, we got to say Compose now supports navigation rail. It is within our material library, so it's really, really easy to do this. We will just use the navigation rail component, pass in a header with our icon, and the two navigation items and their icons. Plus, we're going to pass in the navigation destinations. And that's it. Like, we have a navigation rail set up. Then to integrate it into the app, we're going to make some changes to the top-level component just to make sure it fits into our layout. First, we reach for the window size class with the code that we mentioned earlier to be able to translate window size classes into Compose. And then we're going to gate showing that modal drawer on whether we're on compact, right? So set that up. It's interesting. Sorry, we want to make sure we disable gestures on above compact, just because otherwise if you swipe from the side, the drawer would still come out. So we hook all of that. And then we're going to conditionally show the nav rail next to, you see the nav graph. The nav graph is what contains all of the screens in Compose. So by placing the nav rail right next to the nav graph, we have that structure that we want. And so this is what it looks like now. A bit better, right? Like we've placed this nav rail on the side. Better, but still not great, right? Like that article list is still occupying a ton of space. It doesn't really make sense. So next, we're going to look at list detail. We mentioned earlier, material design has all these canonical layouts that we've published to help inspire in different structures of apps. Well, list detail is one of these layouts, and it will help us show the list of articles next to an open article. To do this in Compose, in JetNews, we have two components that we're going to be reusing. There's post list and post content. Luckily for us, we built JetNews already with a bunch of reusable components, so we built these initially to be able to test much easier our app, right? Like we broke it down to be able to test, but now it's a great tool for us because now we can reuse this and we don't have to start from scratch trying to break pieces down. And because these two don't assume at all that they're occupying the entire space, we can now reconfigure them as we need. So to be able to show the feed and the post side by side, it's actually really easy because we're just going to use a row, which places in Compose two elements side by side horizontally. And then we're going to give the first element a fixed width, and that's going to be our article list. And then we're going to let the other one just occupy the rest of the screen. And voila, we have a row with two elements on the screen. For further niceness, we've added a crossfade. So we've wrapped the detail screen, or like the open article, in a crossfade. And that means that while the user is clicking on different articles and navigating, we'll get nice animations and transitions on the detail pane, which is a nice bonus. An interesting bit to think about now is how do we transition between different screen sizes? So when you're using a foldable phone, the user may be on the large screen and be seeing this list detail layout, and then they'll close their phone and want to look at the screen that is on the outside, which is much smaller. So suddenly our app needs to handle this transition between having a lot of space and being able to show two panes to suddenly only having one of them. So how are we going to handle that collapsing behavior, right? We want to make sure that when the user closes, we see the last pane that they interacted with on top, right? Like if they were actually interacting with the article, we want to close and show the article on top. If they were interacting with the list of articles, we want to show the list of articles. Doing that, turns out, is actually quite simple in Compose. We just added a modifier that records interactions, and we use that further up the hierarchy when we're only showing one pane. We check what was the last recorded interaction, so kind of really easy to handle. The final big decision is, okay, at what point are we transitioning between one pane and two panes? And to do that, we're going to follow the material design guidance and show a single pane for compact and medium and the list detail layout for expanded. Does that make sense? Now, we figured out the UI, but there's still a couple of changes we need to do to navigation, like we saw earlier, to make sure everything works correctly. JetNews was originally built with home screen and article screen having their own view model each. And it's interesting because navigation and view model integration requires that every single destination in a navigation route must have only one view model. That was fine because we were showing these two screens in two different positions within the navigation graph. But now we want to take these two screens and show them at the same time, right? So we suddenly have a conflict. Well, we have two options to proceed. The first one is we can nest a new nav host for the detail pane. That means that within the detail pane, which contains the open article, we could then start an entire new hierarchy of navigation. Or we can take an easier path and just integrate the two view models into one. Note these two choices are the same whether you're doing compose or you're doing sliding pane layout. So if you took the first route and we just added a nav host, this is what it would look like. We would insert a nav host into our hierarchy, and this means that now we can create an entire new dependency graph inside of the article screen. However, JetNews is a sample app, and by that I mean it doesn't really go any further. We don't have plans of doing anything but opening one article screen. So in that case, we took the second option and we decided to unify the view models, just because it simplified the kind of things that you have to understand when looking at our sample. And so this is what it looks like. We just made sure to merge those two into one home view model. Note, however, that we had to make some changes to be able to show from the same destination whether there was one pane or two panes. We created 3 entry points to the home screen now. So we have home feed screen, which just shows the post lists. We have article screen, which shows the post content. And then we have the new home feed with article detail screen, which very descriptively shows both in a list detail layout. Oh, and this is what it looks like now. Okay, we're improving, right? We now have the navigation rail in place. We have the 2 panes. It's starting to really work for this large screen. Beyond the list detail, though, we have done other updates to JetNews, so let me walk you through some of the examples. This is the interest screen. It has just a long list of interests that you can select as favorites, and then it configures the articles to show. But again, if I run it on a large screen, it looks terrible. It stretches, and it's not really feasible. The easy thing we did here is we grouped all of these interests into categories, and we split it into several columns when there's the space for that. And suddenly, it's already a nicer use of the space without having done much. At this point, let me take a step back and talk you through the different elements of Compose, the different composables that are actually going to help you and that we're using in the background to do all of these things. We've seen that when we want to make decisions at the screen level, so say we want to decide if we're showing one pane or a list detail layout, we're going to use window size classes. That's clear. But what about other changes? For example, we may have a card that if in a long list, it's not going to have a lot of space and we just want to show a title and a subtitle. But maybe if we're showing it in a bigger space, we also want to show an image. To do these kinds of changes, you can reach into box with constraints. Box with constraints behaves like a box layout, but it also provides in a scope measurement information that you can use to take these decisions. So for example, do I have enough height to actually show an image? You should be aware, though, box with constraints comes with a cost. Unlike most composables, we can't actually start composing the content of it until after the measure phase because it's giving you that measurement information that you want. And so it may leave less time in the frame to compose other things. So use it with caution. We recommend that you use it when you're actually trying to make different compositions based on size. So you're deciding to show different elements based on the amount of screen space that you have. If all you want is to measure and position the same content just in different ways, for example, what we did with just shifting to 2 columns with the same articles and the same components, we're going to use a custom layout. Custom layout is going to allow you to do the same thing, but it'll be much, much more performant than actually using a box with constraints. So to recap, if you're doing screen layout decisions, reach out for window size classes. If you're going to be composing different things and changing the things that are actually displayed, use a box with constraints. And if you're just going to lay things out differently, use a custom layout. Now, we covered before that one of the pieces of this very fast-growing market is foldables. And let's cover what can we do in this kind of more niche market, but there's really exciting things that we can do to cover foldables. Similar to how we reached out for the Window Manager APIs for window size classes, there's Window Manager APIs that will give you all the features, such as hinges and folds that are in a device. because we're using Compose, we can actually listen for these and react to the different postures much, much easier than we can do views. And we can see if there are postures. So we will listen to features and also to orientations. For example, if you see the example most on the right and the side, that's what we call tabletop mode. And it's when we have a device half folded on a table. And there's really interesting use cases that you can enable on your app using those kind of postures. We've been exploring this in the Jetcaster sample, which is another one of the Compose samples, where we've been looking at how can we use these different postures. And for example, when the device is in tabletop on a table, we can show the controls on the bottom screen and the player on the top screen instead of showing something split between them. So how do we do this? Similar to before, I'm going to show you some integration code that we can do. We are working on making this easier. In the meantime, it's actually easy to do. We reach into WindowManager for the window layout info. We tie it to our lifecycle so that Compose is reading this properly. And then we can map the different information it gives us to postures that we're interested in listening for. So for example, we may want to listen for tabletop. We're going to define tabletop as the case when the device is half opened and in a horizontal position. Then, for example, in Jetcaster, we use this information on the player screen at the very top to say, well, if we're in tabletop mode, we're going to show a different layout from when we are just flat. Sorry, once again, I've mentioned this several times, but we are working on APIs for this. In the meantime, you can look at Jetcaster and see the integration code there, or you can wait for us, and we will be producing a bunch of APIs for this soon. But beyond all of this, we've been hard at work on more of the internals of Compose. In the last few months, we've been really focusing on getting keyboard, mouse, and kind of hardware input really up to scratch. It may seem kind of surprising, but this really enables your apps to work well out of the box in Chrome OS, which is one of the biggest markets we're seeing. So we're really excited to see how Compose can really help enable Chrome OS running Android apps much easier than in the past. And on top of that, I've mentioned kind of new UI development. This scares people sometimes with Compose, like, oh, do I have to do everything new? No, Compose has a great interop story with views. So even if you have an existing app, you can actually consider using Compose to set up the entire structure of your app and continue reusing those fragments and those views that you already have without having to rewrite everything from scratch. If you're interested in more of this, we have a bunch of interop guides published. So check the links on the side and just check, because there are many ways in which you can use views and Compose in your app together. If you want to see all the samples that I've showcased, they're all in our Compose samples repo, which is on GitHub. We've already merged all of the large screen updates that I've shown are already in the main branches of these apps. And on top of that, we've just published a Compose and large screen guide. So please go check that out, and it should give you kind of more of the information that I've given you today and a bit more on how to use Compose while you're leveraging large screens.
So now that we've shown you how to easily update your UIs, to build resizable UIs, let's talk about testing and maintenance. So we know that maintaining UIs across all of these form factors can introduce test complexity. So we're adding new testing and automation tools and APIs to allow you to scale testing across more device profiles without significantly increasing the burden to do so. It's difficult to own physical devices representative of all screen sizes and form factors. So we sought out to provide a quick, seamless approach to run existing instrumentation tests on a variety of screen sizes and API levels through virtual devices. With Gradle managed devices, you can simply describe the configuration of devices you want to run your tests on. And then Gradle takes care of the rest, including device provisioning and test execution to create a consistent, reproducible testing environment. So first, define your devices in your build script. Add them to a device graph, such as a group of devices with medium and expanded with size classes. Then use the group of Gradle managed devices to run your tests. Because Gradle manages both the device provisioning and test execution, Gradle managed devices also supports test sharding, which allows you to split your tests across a specified number of identical devices, reducing your overall test execution time. So simply pass this flag to specify the number of identical instances of each devices that you want to shard your test across, and then Gradle will take care of the rest. But we know that running a large number of virtual devices can be taxing on your CPU and the memory, potentially even limiting the usefulness of Gradle managed devices and test sharding. So to help, Great on Managed Devices introduces a new type of virtual device that is optimized for instrumentation tests. This is called Automated Test Devices, or ATD for short. These devices run in headless mode with disabled background processes and services that you typically don't need for automated testing. So it reduces your overall CPU and memory usage per device. This allows you to run tests targeting multiple devices representing different screen sizes simultaneously. Currently, ATDs are available for Android 10, and then higher API levels will be supported over time. And to make sure that your screenshot tests continue to work with automated test devices, we've updated the Android X testing library with screenshot APIs that dynamically toggle hardware rendering only when required to capture a screenshot, ensuring that automated test devices run as efficiently as possible. While this is a lot of great functionality for how you run your tests, we're also thinking about how to help you write better tests. In particular, testing your app through configuration and device state changes in a synchronous way has always been challenging, and it becomes even more important to write tests for large screens and foldables. So to help with this, we're working on a brand new set of Android X testing APIs that allow you to put the device in different states or postures. So for example, you'll be able to test how your app reacts when your device goes from being folded flat to half open or is rotated between portrait and landscape modes, all with synchronization built in. We're still gearing up for a preview release of this API to first work on virtual devices, so look out for these announcements soon.
We've covered a lot of ground today. We've talked about new design guidance, window size classes. We've covered specific APIs like sliding pane layout navigation, compose, overall testing tools. There's a lot of things to help you on your large screen journey. And large screens and foldables represent such a huge part of the market right now. We really want you to take advantage of this momentum. Now is the time to start targeting these and make sure you are really riding this huge growth in the ecosystem. We're excited to see what you do with everything we've presented and seize this opportunity. There's a lot of new features coming out. There's material design updates, 12L, the Play Store updates, a lot of things happening in Jetpack, both developer APIs and tools. We've only covered a few today, so just make sure you check our newly released large screen guide, which contains everything we've talked about and more, and you will have all the information. Source of truth is over there. Thank you very much.
Thank you.